everybody, welcome. I am putting together a little video to show you how to conduct an analysis of variance using SPSS. And these instructions are a little bit different than the video put together by your textbook authors. So, you can use either method, but I think this method is a little bit better because it gives us a little bit more information. What I have up here is the data file already imported for activity 8-1, where the experiment was to look at different amounts of sleep, either 6, 7, or 8 hours of sleep, and how much time is spent on social media. So, to conduct the analysis, I'm going to, first I always want to graph my data, so I'm going to show you how to create a graph. I'm going to go to the Graphs menu item in SPSS and select Chart Builder, and Chart Builder will ask if my, let me get out of here. Chart Builder is going to ask if my variables are defined properly, and if you notice my independent variable, the sleep group, let me widen that up there, has these little balloons here, like a Venn diagram. That tells me that this is set up as a nominal variable. And the social media time variable has a little ruler next to it. That tells me that it's set up as an interval or ratio scale variable. So this is actually accurate. But if you imported your data, it might, SPSS might choose different labels for the variable. And if you need to fix that, what we want to do is select Variable View down at the bottom. And here's just a list of the variables and how they're defined. And if I go all the way over to Measure, I can pull down a menu and select either scale, ordinal, or nominal. So once again, we want a nominal independent variable and a scale, there we go, a scale dependent variable. Okay, so I'm going to go back to Data View. All right, so my data were already set up properly. Hopefully yours are now as well. So I'm going to go to Graphs and select Chart Builder. Once again, it prompts you to make sure that they're defined properly. And I'm going to reset this because I was playing with it earlier. So you're going to get a screen that looks like this. To build a chart, this is sort of a sandbox over here. I need to select the type of graph that I want from the list. Bar graphs, line graphs, area graphs, and so on. But we're going to stick with a bar graph. And I'm going to just click and drag this first graph type up into that sandbox area, and when I let go, it immediately creates a dummy graph. This has no relationship to our data at all. It's just to show you basically what it'll look like, right? In this case, 3 bars. Now on the x-axis, we always put our independent variable. This is why it was important to define the variables properly. So I drag that down into that rectangle. And notice how it populated that with 6, 7, and 8 hour group names. And then on the y-axis, we put our dependent variable. And so now that it knows to graph the mean social media time on those bars. All right. The other thing that I want to do is go over here to the right where it says Display Error Bars. I'm going to click yes, we want that. And although the default is confidence intervals, I just personally am used to and prefer to, there we go, have the error bars reflect standard deviations, and I just make it 1 standard deviation instead of the default 2 standard deviations. So that's how I would create my graph. When I'm all ready, I click OK. And it opens up a file, and opens up an output file, and you can see the 3 graphs. You can see that the 6-hour group has a higher mean than the 7-hour group, which is also higher than the 8-hour group. And there's the error bar, which is 1 standard deviation. Now, even though these means are different, we don't know if that difference is just sampling error or if it's likely to be due to the time spent sleeping. That's why we have to do our analysis. If you want to get back to your data to look at it, you can just click the orange star icon. You don't have to, because if you're ready to do your analysis, we still have access to all of our menu items in SPSS. But if I wanted to look at my data for whatever reason, if I just click that star menu, boink, it brings back my data file. All right. And my output file is still hiding underneath there. Okay, So now if I'm ready to do my analysis, I'm going to click on the Analyze button. And because we are doing one-way analysis of variance for this topic, for Chapter 8 and Activity 8.1, I can, according to the video put together by your textbook authors, go to General Linear Model, Univariate, and set up an analysis of variance. But here's the difference from from that video to what I'm going to suggest is we can accomplish the same thing with a little bit better info if we go to Compare Means and Proportions. And you see all of the t-tests that we've been working on recently, but there's also a selection, a menu item for One-Way ANOVA. So I'm going to select One-Way ANOVA. Once again, reset this. Okay. And this is what your screen's going to look like. On the left will be the variables on your data file, and on the right is where you will move the variables to set up your analysis of variance. I'm going to take the sleep group and just drag it or press the little arrow icon to move it into the factor box. A factor is SPSS speak or statistics speak for independent variable. And then our dependent variable, social media time, gets moved to the dependent list. And then I want you to check the post hoc box. And then you notice here are all of the different post hoc tests that SPSS is able to do. For Activity 8.1, you are instructed to use the Fisher least significant difference method, which is the LSD. The other one that was discussed in your text is the Tukey test, not Tukey's B, but the Tukey test. So if you needed to use Tukey, that's where you would find it. I'm going to uncheck it because, once again, with just 3 groups, the least significant difference method is fine. So click Continue. Now I'm going to click Options. And for options, we want descriptives, so it will tell us the means and the standard deviations and all of that for each group. I'm also going to have it do a homogeneity of variance test. We're going to do that Levene's test and make sure that that assumption is properly met. So those are the 2 things that I'm going to check, and I'm going to click Continue. Now we're pretty much done. Just a double check that estimate effect sizes for overall tests is also checked. It was the default for my version of SPSS, but make sure that that is checked so that we get the effect sizes that we're looking for. And when I'm all ready, I'm going to click OK. And it brought back my data file. Here was the graph that we created a little bit ago. Notice we see the first table is the descriptives, so you can see the average amount of time spent on social media for the group that got 6 hours of sleep, 7 hours of sleep, and 8 hours of sleep, standard deviations, standard errors, confidence intervals, etc., etc. Here's that homogeneity of test that we requested, and we just need to pay attention to the very first row. This is Levene's test based on the means. And if we go all the way over here to the sig column, that's our p, this is the instance where a high p-value is good because it suggests that the standard deviations, to the extent that they differ, and they all differ by just a little bit, is just due to regular old sampling error, right? There's a very high probability, 0.76. Or 76.6% chance that these differences are just sampling error, and that's a good thing. We don't want them to be different for, a real reason. So now we can ignore the test of homogeneity of variance, and then below that is the ANOVA summary table. And this summary table is a lot cleaner. There's less information than in the general linear model approach that the textbook authors instructed you to use. Here's the between groups variable, which is our independent variable. If you remember, there were 3 sleep groups, 6, 7, and 8 hours, which means there are 2 degrees of freedom. 3 groups minus 1 is 2. And if we skip the mean square, we can go to the F value. Our F is 5.847. And then there's the p-value. But before I talk about the p-value, our within groups variable is also our error term. It is the variability that is due to individual differences, okay? So there's the degrees of freedom, mean square. So if we take the mean square between and divide by the mean square within, 29,928 divided by 5,118, we get 5.847, which means there was 5.847 times more variability between the group means than there was within each group, individual differences. And the probability of getting an F value that large or larger just because of sampling error is 0.003, which we would interpret as being pretty small. There's only a 3 in 1,000 chance that an F value this large or larger would occur just because of sampling error. So these data are not compatible with the null hypothesis, because the null hypothesis would suggest that any differences are likely to be due to sampling error and nothing else. All right, so that's the omnibus F test. Below that, we have the effect sizes, and here's another difference when you use the one-way ANOVA option. SPSS will calculate the omega squared value that was discussed in your chapter, but it does not calculate that if you use the general linear model approach. But here's that partial eta squared calculation of 0.062. That's the effect size for eta squared. And if we look at omega squared, which is a little bit better, less biased, and so you should use it if you have access to it, if your software calculates it, we see the effect size of 0.051. And you would interpret the effect sizes just like you were instructed in the textbook. And so look up those ranges to decide if it's a small, a medium, or a large effect. Okay, if you have omega squared, you should use that. If you don't, partial eta squared is quite commonly used. All right, and it does give us effect sizes around the confidence interval. And then lastly, at the bottom, we have the multiple comparisons table. This is where we had the post hoc test, the Fisher's LSD test. And to read this, we just look at whatever group is in the left column, the sleep group column, and whichever one is in the next column, and that's the comparison that we are conducting. So if we're looking at the difference between the 6-hour group and the 7-hour group, we see that difference was a little bit more than 29 minutes, almost 30 minutes difference between the two. And if we skip over and look at the SIG column, this is the probability of getting a difference this large or larger just due to sampling error. And we see that that difference is 0.023, which is fairly small, and therefore not likely to be due to sampling error, not consistent with the null hypothesis. And then we are also given the 95% confidence interval, so we can be 95% sure that the actual difference between the population, if we could test all human beings who got 6 hours of sleep to all human beings who got 7 hours of sleep, there's a 95% chance that the difference between them is somewhere between 4.15 minutes and 55.7 minutes. All right, so that's the 6 to 7 hour group. Now, if we look at the 6 to the 8 hour group, there's a 43.68 minute difference between the two. And the probability is 0.001, which again is quite small and therefore not compatible with the null hypothesis. This difference is likely to be very real. In both instances, if we look back at the means, you can see that the 6-hour group spent more time on social media than the 7-hour group and the 8-hour group. So there's something different about that 6-hour group, because they are spending way more time than we would expect just due to the sampling error than the other two groups. And once again, we have the 95% confidence interval, that we can be 95% sure that the actual difference between the populations of 6 and 8 hour sleepers is 17.9 minutes and 69.46 minutes. Now, we've compared group the 6 hours to 7 hours and 6 hours to 8 hours. That leaves one more comparison. We have to compare the group that slept for 7 hours to the group who slept for 8 hours. So if we continue down on the left column, there's the 7-hour group and there's the 6-hour group. And that's a funny thing about SPSS, is it does a lot of extra comparisons. We already compared the 7 to the 6-hour group. Right up here, we have 6 to 7 hours, 29.92 minutes difference. Well, if we look at 7 versus 6, we get a negative 29.92 minutes difference, because just the way we subtracted 7, the 7-hour mean minus the 6-hour mean, or the 6-hour mean minus the 7-hour mean. It's the same number of minutes difference, the same p-value, it's the same confidence interval, etc. So we can skip that one. And the next one down is 7 hours to 8 hours. There was a 13.75 minute difference between those two, with a p-value, a sig value of 0.294, which is pretty high, all right? Almost a 30% chance that this difference is due to sampling error. And that's really too likely, too consistent with the null hypothesis to say that these groups, the 7-hour and 8-hour groups, differed by anything more than sampling error. And if we look at the confidence interval, where there's a 95% chance that the actual difference between these two groups is somewhere between negative 12 minutes and positive 39 minutes. So notice that sign switch that really tells us we're not sure at all what the actual difference is. It could be anywhere from the 7-hour group being higher or a 7-hour group being lower than the 8-hour group. And the last two rows we can ignore because they're also duplicates. We've already compared the 6-hour group to the 8-hour group up here, and we've already compared the 8-hour group to the 7-hour group here, so we can ignore that. So of the 6 comparisons, we only had to pay attention to the 3 unique ones: 6 to 7, 6 to 8, and 7 to 8. And that, my friends, is how to conduct an analysis of variance, a one-way analysis of variance for activity 8-1. You would do it the exact same way for any other ANOVA, using the compare means one-way ANOVA command rather than the general linear model approach. I hope that was helpful. Let me know if you have any questions at all.